sklearn, neighbors, nearest centroid. Description. Nearest centroid is a classifier that uses the mean of the samples in each class as the centroid for that class. When predicting the class of a new sample, it finds the centroid closest to that sample and assigns the class of that centroid. This method is simple and efficient, particularly for high-dimensional data. Inputs: X the training input samples as a 2D array of shape n samples. N features. Y the target values as a 1D array of shape n samples. Outputs: Self the fitted nearest centroid object. PredictX the predicted class labels for the input samples X. Steps. Training the algorithm computes the mean of the features for each class in the training data. This mean becomes the centroid for that class. Prediction given a new sample. The algorithm calculates the Euclidean distance between the sample and each centroid. The class of the closest centroid is assigned as the prediction for the new sample. Metrics. Accuracy the percentage of correctly classified samples. Precision the ratio of true positives to the sum of true positives and false positives. Recall the ratio of true positives to the sum of true positives and false negatives. F1 score the harmonic mean of precision and recall. Visualization plots. Scatter plot. This plot shows the distribution of data points and the centroids for each class. Decision boundary. This plot shows the boundaries that separate different classes based on pay. Nearest centroid rule. Fine-tune parameters. Metric. The distance metric to use for finding the nearest centroid. Common options include Euclidean, Manhattan, and cosine. Shrink threshold controls the shrinkage of the centroids towards the grand mean. A higher value shrinks the centroids more. Uncertainty methods. Distance to centroid. The distance of a sample from its nearest centroid can be used as a measure of uncertainty. Higher distances indicate greater uncertainty in the prediction. Challenges and fixes. Challenge 1. Outlier samples. Outliers in the training data can significantly shift the centroids, leading to inaccurate predictions. Sample use case that resulted in challenge 1. A training dataset containing a few very large values in a specific feature. These outliers might pull the centroid for that class towards them, even if they represent a small portion of the data. Fixes to challenge 1. Data preprocessing. Consider outlier detection techniques e.g. Z-score, IQR, and remove or cap outliers before training. Robust estimators. Use robust estimators for computing the centroids e.g. trimmed mean that are less sensitive to outliers. Challenge 2. Nonlinear data. Nearest centroid assumes linear separability between classes. It may not perform well when classes are highly nonlinear or overlapping. Sample use case that resulted in challenge 2. A dataset where two classes form concentric circles, making it difficult to separate them linearly. Fixes to challenge 2. Feature engineering. Create new features that capture nonlinear relationships. Nonlinear models. Consider using more sophisticated nonlinear models e.g. support vector machines. Decision trees for these cases.